Alright, so here's how you do the homework last night. If it says solve by graphing, and that's what numbers 1 and 2 were, you've got to go through and actually graph both of the equations. So I'm going to color code it to make it just a little bit easier to see. We're going to put the first equation in red. Our y-intercept is -2, so that means I come down here to the -2 on the y-axis, and I put a dot there. My slope is what's in front of this x, and that's a +1. So I would go up 1 and to the right 1. Up 1 to the right 1, up right and to the right 1. And so I could extend that as far as I want to. My line's a little shaky right there. But now I come back to this one and I go, you know what? Let's graph this line in black. My y-intercept is going to be -4. And the slope for this line is going to be +1 also. And because it has the same slope but different y-intercepts, I've got parallel lines. These lines are never going to touch, and so since they're never going to touch, I know that I have no solution for the answer. Number 2, I see right away I have the same slope and different y-intercepts, so technically I know it's no solution, but the directions do say solve by graphing, so I've got to graph them. So here we go. +3 is my y-intercept. And my slope is -1/2, so I'd go down 1 and to the right 2, down 1 and to the right 2. Connect my points. Hopefully you can do a better job on that on paper than what I can on this digital pad up here. So here's the first graph in black. The second one we'll put in red this time. My y-intercept is +4, so it's right above it, and I go down 1 to the right 2, down 1 to the right 2. And just like on the first one, these lines are not going to touch. So, no solution. This one, we want to use the substitution method, so there's no graph that's given, and we need to go solve it. Basically, you look for the situation where the variable is all by itself. The x is not by itself here, the y is not by itself there, but down here, this y is literally equal to x. So that tells me that if I come up to this first equation, any place that I see a y, I could take out that y and I could put in an x. So let's write down that first equation. -4x minus 3y equals -14. We said that y is equal to x. So this y I could take out and make it an x. All we have to do now is combine like terms and solve the equation. So -4x minus 3x is -7x. The -14 comes down. I divide both sides by -7. And x is +2. Well, that's great. We've got half of our solution. I now have the option of taking this x value of 2, and I can make the x a 2 in either of the equations. I can make this x a 2, or I can make this x a 2, and then I'd be able to solve for the y. Well, the second equation sure does look smaller, so let's just use that one. We said that any x is going to be equal to 2. So this x right here is going to be replaced with a 2. Y equals 2. We're done. The x is equal to 2, the y is equal to 2. There's our ordered solution. Excuse me, an ordered pair, which is the solution to the SOE. For number 4, it's slightly different than the one before because this time our x term has a coefficient of 2. And we're going to treat it pretty much the same way. Anytime that we see a y, we're going to replace it with a 2x. So this y right here, we're going to replace that y with a 2x. Now, before we go and do that, remember this 3 is multiplying that y. So when we pop out that y and make it a 2x, this 3 has to multiply the 2x. So let's go ahead and rewrite the equation. Again, we said that anytime we see a y, we can replace it with a 2x. So here's our y, where we're going to replace it with a 2x. And it's a positive 2x. But this y was multiplying the 3. So when this 2x replaced that y, it still has to multiply this 3. So it's not 32x. We've got to make sure that we know that this replacement for the y value is going to be multiplying the 3. So 3 times 2x is 6x. And I already know that this is a positive 3, and that's a positive 2x, so positive times positive makes it positive. And I can just pull down this 3x there and pull down the 9. Now we just combine like terms and solve. 3x plus 6x is 9x. Divide by 9, divide by 9, and x equals 1. Now, we always have to make sure that we come back and get our other value. We've got our first one. It's x equals 1. So my ordered pair, I know that it's a 1, but I don't know what my y is. If we look back into our equations, we have the option now of making any x into a positive 1, and then that would get rid of the x from the equation, and we could solve for y. Go for the easiest equation. It looks like it'll be y equals 2x. Well, that 2 is multiplying the x. If I knew what the value was, I could figure out what the y is. Well, x is 1. So 2 times 1 is what we're going to do, and 2 times 1 is 2. So y equals 2, and we're finished with this problem. This is the solution that makes both of these equations true. So let's take a look at this one, and let's go solve. Y is equal to 4x, so it's 8x minus 2y. Well, we said that y is equal to 4x, so let's just plug in that 4x. Same thing, that 4x was the y, and it's going to be multiplying the 2. Well, this is 8x. Do you see how this has got a minus sign in front of the 2? Well, this negative 2 is going to be multiplying the this negative 2 is going to be multiplying the positive 4x. Negative 2 times 4x is negative 8x. And this pulls us into a very interesting situation. Okay? Remember that when we're graphing two lines, if they're parallel, they never touch, and we call that a no solution. When we do the substitution method, though, we don't see the graph. But we've got to be able to detect what a no solution situation looks like, and that's what this is actually going to show us. Because 8x minus 8x is, well, 0x. That's an issue. Because as soon as I divide 0 divided by 0, well, first off, that's going to be 0 still. 0 times x is going to be making it nothing. It's like that whole x term blew up and there's going to be nothing here. Like nothing at all. But let's just say that you make a mistake and you want to call this 1 or you call it 0x and you're fine with that. Because I divided the left side by 0, this right side right here, this is where it should be telling you something's wrong. 1 divided by 0. That becomes an error. If I take 1 and I divide it by 0, I get an error. So let me just kind of pull this one down here. So on my calculator screen, there's 1 divided by 0, and it tells me that there's an answer that's an error because you can't divide anything by 0. So as a result, I need to be very, very careful that I don't go through there and just say that x is equal to 0, because it's not. It's actually undefined, or it's called an error. And as soon as you get one of these right here, you stop and you go, cool, no solution. I don't have to think about it anymore. Six, 7, and 8 are much easier on the homework here. Y is equal to negative 10x, so let's just kind of speed it up and let you see what it would look like. That minus sign is right there. The y is going to be replaced by a negative 10x. So just be careful when you plug that in. When you see the minus negative situation, that means that you could rewrite it as a plus, because that keep change event that's going on. Negative 7 plus 10 is positive 3x. And now we can divide by 3. Now this is different than the other situation. We've got the 3 on the bottom. The 3 is doing the dividing. If I type in my calculator 0 divided by 3, it's going to show me 0. It's not going to show me an error. It's going to show me 0, and I'm fine with that. So I know that my x value is 0. So now I can take the nice easy equation of y equals negative 10x. Or I could take the first equation, which is more work, but hey, you know, I don't want to do more work. I'm taking the easier equation. And I make this x into a 0. And then that lets me be able to figure out what my y is. So negative 10 times 0. Well, that means y is equal to x, because negative 10 times 0 is 0. My ordered pair in this case is 0, 0. Moving on to number 7, we've got the same thing again, except for this is a negative 4x. So 6x plus 9, and this 9 is multiplying the y. Well, y is equal to negative 4x. So I've got to show that that negative 4x is still going to multiply the 9. We'll go through and, whoops, sorry. This positive 9 is going to multiply the negative 4x, so that's negative 36x. Now I can combine like terms. 6x minus 36x is negative 30x. Divide both sides by negative 30 and x equals 1. And as you can see, it starts to get a little bit easier now. Excuse me, that's a negative 4x there. Let me fix that. So y is equal to negative 4 times, the x is a positive 1. So negative 4 times 1 is negative 4. There's our ordered pair, 1, negative 4. And here's the very last one I wanted to show you. Y equals negative 5x. This time they gave it to us with an isolated variable on the first equation. So that means where this y is, I'm going to replace it with that negative 5x. So negative x plus 2 times negative 5x equals negative 22. Let's go ahead and do this right here. That'll give us a negative 10x when we multiply these two values together. This is the same as the negative 1x if you want to look at it that way. Keep change, so it'd be negative 1x plus negative 10, or your final answer is negative 11x. Divide both sides by negative 11, and x equals positive 2. So choose the easy equation. Whatever you see for x, we know that it's now equal to positive 2. So y equals negative 5 times positive 2. Well, negative 5 times 2 is negative 10. So our solution is 2, negative 10.